In this video, we're going to look at how we go about evaluating limits of functions that are not continuous at some point. How do we find the value of the limit at that point at which it's not continuous? So if we have a function that is not continuous at C, and by continuous for now we are going to mean essentially intuitively, can we draw that function, a picture of that function, without lifting up our pencil when we are drawing it? Right? So that will be our idea of continuous. We will formally define what it means to be continuous later, but that will be our idea for now. So if we have a rational expression, so we have one function divided by another, then we can simplify that rational expression by canceling out common factors, or at least we can attempt to do this when we're trying to evaluate the limit. So if we can cancel out common factors, then that is one strategy that we will use. If f of x is a rational expression with a radical in either the numerator or the denominator, we might try to rationalize the numerator or the denominator, and then see if that cleans things up, allows us to evaluate that limit. We might use the squeeze theorem, which we will talk about here a little bit later on. There are some special trig limits that we might make use of, and we will talk about those. And if all else fails, we can evaluate the limit numerically or graphically. Right? So using processes that we have previously talked about, that we initially looked at prior to evaluating these things analytically. And so in this video, we're just talking about those, mentioning these 5 strategies. In the subsequent videos, we will look at specific examples where we use each one of these 5 strategies. These are strategies that I would employ if direct substitution is not going to work because the function is not continuous at that value C. You might have a value that's not in the domain of that function. All right, in the next video, we will look at examples that deal with this first case. We will see you there.